Hi friends, welcome back to my YouTube channel. Hope you all are doing good. So today we will start chemical kinetics. So very first question, what is chemical kinetics? So it is the branch of chemistry which deals with the rate of reaction and the factors which influence the rate of reaction and the mechanism by which the reaction proceeds. So what things? It deals with the rate of the reaction and the factors which influence the rate of the reaction. So now the first question, what is the rate of reaction? As stated here, it is the speed with which the reactants are converted into products, and it is measured as rate of decrease in the concentration of the reactants or increase in the concentration of the product with time. So it is obvious, like when a chemical reaction is taking place, the concentration of product will decrease with time and the concentration of the concentration of the reactants will decrease with time and the concentration of the products will increase with time. So by the speed by which this reaction is proceeding is known as the rate of reaction. So now how to express the rate of reaction? Like there is expression for everything, like initially we discussed the equilibrium expressions. Similarly, rate of reaction also has expression that is known as the rate law. So what is rate law? It is a mathematical expression which denotes the rate of a reaction in terms of the molar concentration of the reactant with each raised to the some power which may or may not be same as stoichiometric coefficient of the reacting species in a balanced chemical equation. Now what it means? So very first question, molar concentration. What do you mean by molar concentration? So molar concentration is basically the molarity. So it is expressed in terms of the molarity of the reactants, and that molarity is raised to some power. Okay. So now what it means? Let us understand this with the help of an example. Suppose I'm writing an example, reaction between so there is a reaction between NO2 plus fluorine gas giving rise to formation of NO2F. So how to express the rate of reaction? Basically, rate of according to the rate would be expressed will be equal to K times the molar concentration of NO2 times molar concentration of the F2. And they are raised to some power. Like here it is 1 and here it is also 1. So this is the rate of reaction. So what is K? K is known as the rate constant. Rate constant, and it measures the rate of reaction. Okay, I hope this is clear. So what was the definition saying? Molar concentration of the reactants. So square bracket denotes the molar concentration. We took the molar concentration of NO2 and then we took the molar concentration of F2. So molar concentrations raised to some power. So here is the power which may or may not be equal to the stoichiometric coefficient. So what is the stoichiometric coefficient? The stoichiometric coefficient here is 2 and here is 1. So obviously 2 is not equal to 1. So which may or may not be equal. Let us take another example. Suppose we have 5 Br negative aqueous plus BrO3 aqueous plus 6H positive. So giving rise to Br2 plus 3H2O. So how to write the rate? So first write the rate, put the rate constant K, then write the molar concentrations. So molar concentrations of Br negative, BrO3 negative, and H positive. And now they all are raised to some power. So here this is 1, 1, and for this it is 2. So how to calculate these powers? Powers are experimentally determined. you won't be able to calculate them. They must be given in the question. Okay. Fine. I hope this is clear. So this is the rate law expression. Now we will discuss about K, which is our rate constant. Now what is K? Let us discuss about K now. So K. So rate constant measures the rate of reaction. Larger the value of K, faster is the reaction. Similarly, smaller the value of K, slow will be the reaction. So different reactions have different value of K. Suppose you have a reaction A plus B giving rise to C and Q plus R giving rise to P. So the rate of the reaction for this would be K1 concentration of A and concentration of B. For this one, the rate would be K2 concentration of Q and concentration of R. K1 won't be equal to K2. They are different. Fine. For the different reactions, the value of K is different. So at a fixed temperature, the value of K is constant. Now what it means? Like suppose you have again this reaction A plus B giving rise to C at, let it be 298 Kelvin, and same reaction taking place at A plus B giving rise to C at 300 Kelvin. So here, so you have two different temperatures and the value of K will be different at different temperatures. Here the K value, let it be K1, and here the K value equals to K2. So K1 won't be equal to K2 because the value of K is affected by temperature. So value of K is independent of the concentration. As the concentration changes, the value of K is not going to change. It is constant. Okay. So independent of the concentration of the reactants. Next, we have order of reaction. So what is it? The sum of the powers to which the concentration terms are raised in the rate law equation to express the observed rate of the reaction. Okay, now what it means. So let us take a hypothetical reaction. Let me write here A plus B plus C giving rise to products. So how you will write the rate? Pause the video and write the rate law expression for it. So rate would be equal to a constant K, molar concentration of A, molar concentration of B, and molar concentration of C, each raised to some power. So let me write here PQR. So now what is the definition of order? So order say it is the sum of the powers. So order would be sum of the powers. Sum of the powers means sum of P, Q, and R. So P plus Q plus R, you need to add them together and you will get the order of the reaction. Hope this is clear. It is the sum of the powers to which the concentration terms are raised. Provided in rate law expression. First, you need to write the rate law expression and then you need to find it. Okay. Now let us do some examples. So these are not hypothetical examples. Suppose you have N2O5 giving rise to NO2 plus half O2. So rate is expressed as K and concentration of N2O5. So what would be the order of the reaction? So this is raised to power 1. So there is nothing here. So there is a 1 here. So order is 1. So this is known as first order reaction. First order reaction. Okay. Let us take another example. H2 plus I2 give rise to 2HI. Rate would be, if the rate is equal to H2 and I2, find the order of the reaction. So order would be, you need to add them. Here is 1 and here is 1. 1 plus 1 equals to 2. So this is second order reaction. Second order reaction. Hope this is clear. Okay. So the rate of the reaction could be fractional also. Suppose, the one we discussed here, these are experimentally calculated. These are not hypothetical examples. They really happen. So dissociation of N2O5 is first order reaction, whereas formation of hydrogen iodide is a second order reaction. So the rate of reaction, the order of reaction can be fractional also. Suppose let us take this aldehyde reacting to form methane plus carbon monoxide. So here the rate is equal to K, molar concentration of the reactant, square, and 3/2. So the molar concentration is always expressed in square brackets. Don't make these kind of parentheses, okay? You need to use the square brackets. Now the order would be 3/2, correct? So this is a fractional rate order. Fractional order. Hope this is clear. Now next, let us move to a really interesting zero order reactions. So these are the reactions in which the rate of reaction is independent of the concentration of the reaction or the reactant. Now what it means. Let us take a reaction, formation of a dissociation of ammonia. So 2NH3 in presence of a catalyst, platinum, N2 plus 3H2. So now here the rate of reaction which is calculated experimentally is this. So what is the order? So now what is the power? Power is 0, correct? So this is known as zero order reaction. The reaction in which the rate is independent of the concentration of the reactant. Like it is not going to depend on the concentration of the reactant. No matter how much reactant you take, the rate depends on some other factors. Other factors can be the physical conditions like temperature, pressure, or the use of the catalyst or the amount of the catalyst you are using. So there are some other factors which affect the rate of reaction. Okay, so this is a zero order reaction. Okay, now let us discuss one more. So if I say rate law expression is given as K, A 3/2 and B -1. Find the order. So this is for you. Find the order of the reaction and send us to the email. Email would be given in the description box. You can just use that mail. And one important information, our institute also provide one-to-one online tuitions in chemistry. So if you want any related to any topic, you can just text us. Okay. Hope you like the video. If you like it, do share it and subscribe the channel. Bye-bye. Take care. Happy learning.